Okay, so what are we going to do today? We're going to spend the next 2 weeks on Pythagorean theorem. Well, that's done. We're going to talk about sine, cosine, and tan. So this booklet here, this booklet is sine, cos, and tan. So who remembers the sine, cos, tan business? Who remembers sine, cos, tan? Okay. Now, this is going to be smooth sailing for you because it's just a review. SOHCAHTOA, yes. Now, keep in mind, and out of respect for the entire class, that there are people here that haven't been in school for a while, and maybe when they were in school back in the day, they weren't too good at this stuff for whatever reason. So I'm not teaching this to the top student in the class today. So the top students that are really, really good at trigonometry are probably going to just kick it back in their chair, maybe have a coffee and just chill. But I really need to address the lower half of the experience here because maybe they haven't seen this in a while. And the goal is by the end of this week that you're a little bit more confident so that we can go at a more comfortable pace for the entire group. So what I'm going to do with you today is pretty close to sections 5.1 and 5.2. I'm going to focus on those two today. And then next time we'll do 5.4, which is Friday. And there's some degrees, minutes, seconds, which we talked about already, but I'll do a little bit extra on Friday for that. 5.3, we're not covering it because it's using older technology for doing trigonometry. Like before people were using calculators, they were using tables. And then next week, we're going to do 5.6 and 5.7. And with whatever remaining time we have next week, I may start chapter 6 a little bit. I might just do a couple of questions from there just to get us started on that. So let's do 5.1 and 5.2 today. The key word for today's lesson is communication. We're going to talk about labeling and describing information on triangles. Very critical to you to do trigonometry. So if we take a look on the second page of the notes here, we have these words called hypotenuse, opposite, and adjacent. So what you need to know how to do in this first section is really coming down to the labeling. So we're talking about a right angle triangle. See this right angle triangle here? And the goal is to label the triangle relative to one of these angles. Maybe it's this angle here, this Greek letter theta, or maybe it's this other Greek letter phi. So let's just say you choose this angle theta over here in the bottom. Then you can label the triangle relative to that angle. In terms of labeling, you always start with the hypotenuse. See, the hypotenuse is the side that is opposite the right angle. Thank you, Shalan. The hypotenuse is opposite the right angle. It doesn't matter which one of these two angles you choose, the hypotenuse will always be this one because the right angle is fixed on this diagram. Now, you can choose either the one down here or the one up here. I chose the one down here, so there you see it, and relative to that angle, you can label the other sides. So if you look across over here, the angle is in a sense pointing to this side. So that's why this is called opposite, because the angle is opposite to that side. And then the other side, which is over here, is beside the angle. The word adjacent is synonymous with the word beside. Like you can say your neighbor lives beside you, or you could say your neighbor lives adjacent to you. So this side here is beside the angle or adjacent to the angle. Now you might say, hey buddy, wait a second. The hypotenuse is also adjacent in a sense, it's beside. However, it already has a name, doesn't it? It's already called the hypotenuse. So who cares? It's already labeled. So in this section, honestly, all you have to do for this section is label the figure. So we're gonna do that right now. We'll spend like 5 minutes or less. I don't think it's too painful. And this might be the shortest lesson you have with me today. Who knows? But anyway, there's the three triangles, and the goal here is to label the triangle relative to the angle. So as you can see here, it says your answers on page question mark. This is a draft of the notes, so I haven't linked the page numbers. So anyway, the answers are down here actually, but we can do the question without looking at that answer key. So I'm just gonna scroll it in big time there, zoom it in a bit. There we go. So what I want you to do now is help me label these three triangles according to the angles. So I'm going to start with a triangle over here. This angle is theta. Okay, Shalon. I'm going to go baby steps, my friend, baby steps. You're rocking it there. So what's the Denny, what's the y for? What are you asking y for? Denny, do you have a question? Oh, like why is this one theta and why is this one that one? It's just arbitrary. I'm just giving you the label of it here. There, you don't have to, like, all we're doing is labeling the triangle relative to the known angle here. So we're going to label the triangle relative to this angle, whatever the angle is. Yeah, this one's theta and the other one's phi. Well, they can't both be theta because unless they're both the same angle. Like, they have to have different names. So I can call this angle here something else like gamma or alpha or whatever letter you feel like. There's 24 letters in the Greek alphabet. Knock yourself out. Anyway, so we're going to use this angle theta. Now, let's go really slow, everybody. What is the first thing that I should label? Should I label the opposite, the hypotenuse, or the adjacent? Which one of those three should I label? Thank you, people. Yes. And where is the hypotenuse? Are we going to play hot or cold? Just kidding. No, the hypotenuse is over here. I'm going to write here hypotenuse, HYP, the long side. Yeah, it's the longest side. Exactly, Malik. Now, I wrote HYP for hypotenuse, but if you want, and what I'll do in the long run is I'll just write the letter H, and sometimes you'll see me circle it. I don't care if you do like that fancy, but I'll just put hypotenuse for now. Okay, what's this one called? Is that opposite or adjacent? Yeah, that's opposite. And if you're wondering, think of it this way. Remember, this angle is pointing or facing that opposite side. And then the other one, well, the other one's the adjacent. And then you're done. Okay, I'm not asking anybody to go out on a limb here, but who has not seen this in a long time? Like, there's got to be people here, and I know that, I respect that. So hopefully Malik, thank you, George, Shalon. So wow, Julio, 3 years, yeah. You know, honestly, 3 years, I would probably start forgetting this stuff too. So yeah, that's a bit of a long time, Denny. It's funny, my niece was like asking me for help in biology, and I've been out of high school for like 25 years, and she's asking me for help in biology, and she's like, "Do you remember genetics?" And I'm like, "Well, it's been 25 years." I'm like, "I'll pass. Sorry, sweetheart, couldn't do it." Chemistry, I could help her. Math, no problem, but not biology. Don't remember anything. Anyway, it's okay, Matthew. This is your time to shine because you got me, you got your friends in this class, and we're gonna help each other kick some butt. Okay? That's what we're gonna do, Matthew. So let's talk about this triangle. So which side is the hypotenuse? Remember, you always want to label the hypotenuse first. You always want to do this one first. Where is the hypotenuse on this triangle? L to N. Yes. Now I'm gonna put a capital H there. Thank you, Denny. That's a capital H for hypotenuse. So instead of me writing this whole word out, I don't think that's going to be very efficient. I'm just going to write the letter H, and I might circle it if there's variables involved elsewhere. So now we're going to go with the opposite. So the opposite is MN, yeah. So when I write O there, it doesn't mean 0, it means opposite. And this arrow thing, I don't care if you write the arrow, but we're just labeling stuff, so it's a good opportunity to do that. And then finally, this guy up here is the adjacent, which is LM. Yes. So yeah, that's pretty much it. Let's go through this last triangle and try the same thing. So this one here is AC is the hypotenuse, yes. And I'll just use this arrow thing here. So that's the opposite. And Malik, yeah, thank you. AB is the opposite. And the adjacent is BC, yes. Sorry, if you're wondering why I'm going slow, it's because I'm reading like the chat messages as I'm drawing. So I'm not that slow, don't worry, it's just reading. Anyway, there you go. Mission accomplished. You now have familiarized yourself again with how to label the triangles. So once you label the triangles, then you can start to use sine, cosine, and tangent, which is the next topic. And there's a very important word here. The most important word on this page for me is this: definitions. So why am I so keen on that word? Because what I'm showing you, these boxed items here, which are the definitions for sine, cosine, and tangent, I want to emphasize that word definition. It's defined. It means someone made it up because they felt like it. Or some people made it up because they felt like it. Like if someone asked me, why is my name John? Because my parents named me John. It was a definition. Someone defined my name to be John. There was no mathematical formula. It wasn't based on the physics of the universe. It was based on people giving me a name or a label based on their definition. So that's what I'm talking about here with definitions. Definitions are often irritating to people because they think that there's something of a deeper meaning behind it. Mathematically, it comes down to convenience and tying things together in the big picture with math. So sine, big word here, is defined as the ratio of opposite over hypotenuse. Cosine is defined as the ratio of adjacent over hypotenuse, and tangent is also a ratio that is defined as the opposite to the adjacent. So these ratios are defined, and we can streamline them into the following equations. So you see them down here. But as mentioned in the chat, who remembers the shortcut? Who remembers the shortcut for this to memorize all this stuff? What's the shortcut that allows you to remember all of these things? Sine is opposite, cos, etc. What's that? Yeah, keep on going. Keep on going, Malik. There's 9 letters. Yep. Thank you, Michael. Yes. SOHCAHTOA. SOHCAHTOA. So there it is. And I'm just going to write it big bold letters here. So this is really a memorization tool for remembering these definitions. What we're going to do now is take these definitions and just make sure that you're comfortable using them with some triangles. And we'll spend some time doing that for the rest of today. If you're wondering, are we doing any problem solving today? Are we going to solve for an angle? Are we going to solve for something? No, no, no. the word solve, I don't want you to use the word solve today. We are not using the word solve today. All we're doing today is familiarizing ourselves with the definition of sine, cos, and tan. That's it. So we're not doing any like intense application. We're just familiarizing ourselves with the definitions. So let's take this definition. Whoops. Let's take this definition here and do a question. So we're using this definition to answer the following question. It says, calculate the decimal values for 4 decimal places for sine, cos, and tan of this Greek letter here. If you're wondering that Greek letter, the pronunciation is phi, or you can say phi, but the proper way is phi, like feet without the T at the end. And then we're going to do that for the following triangle. We'll repeat this process for a couple more triangles, time permitting today. And then we should be good to go for moving on to applying it for questions next time, doing some application next time. So, just gonna write it down here. Oops. So how's everybody doing? Did you have a good weekend? While I'm doing some housekeeping here. No good weekend? How come? What was it? Were you working? Was it the weather? Ah, okay. I gotcha. I stayed in Toronto. I stayed in Toronto the weekend. Hibernated like a hermit. But that's okay. It's okay to do that once in a while. Before we can end, whoops, I wrote cosine twice. I'm so sorry. That was silly. So the first thing you want to do is label the triangle. So let's label this triangle. So when you look at the right angle triangle, where's the hypotenuse? Which one of the numbers is the hypotenuse? Thank you. So that's the hypotenuse. Where's the opposite? Which one's opposite? 12. And then the adjacent is this one over here. Back when I was a student learning this the first time, I just labeled, when I learned this for the first time, I would just label the hypotenuse and the opposite, and I knew that those were right. I was 100% confident with those. So then I just said the leftover was the adjacent. I know that's kind of like not the most elegant way to do it, but it was safe. Anyway, going back on the definition here, sine is opposite over hypotenuse. So in this case, the opposite is 12, and the hypotenuse is 13. So the answer is 12 divided by 13. Can someone give me 12 divided by 13? 4 decimal places. Sorry, Ram. Thank you, Ram. 4 decimal places. Anybody have it to 4? Thank you. Okay, cosine. Adjacent over hypotenuse. So the adjacent is 5, and the hypotenuse is still 13. What glorious numbers, eh? What's 5 divided by 13? Thank you. You know, if you put me in a quiet room, I can do these in my head, but I'm too lazy. Plus, I got to manage a conversation with 32 people at the same time, so it's not happening. So thank you for your computational skills. Okay, next one. If you put your mind to it, you probably could do. This one I can do in my head. 12 divided by 5. Because divides by 5 is easy. 2.4, right? That's not bad. It says to 4 decimals, but you don't need to put the 4 decimals here because it's already accurate. It's 100% accurate here. So the question I have for you, very, very subtle question, but it's a good one. Can someone tell the class this number right here? What are the units? What are the units for this number? That is correct, Daniel. That is correct, my friend. There are no units. There are no units. This number, 0.9231, is a ratio. Like, for example, if let's say that I'm 40 years old and my niece is 10 years old, I'll just make that number up, then I'm 4 times as old as her. The 4 times does not have units to it. Same thing here. 12 over 13, the meters, they just cross right out. They just cross right out. So it's really important that you understand that there are no units to a ratio, because by definition, a ratio should not have units. They should cross out. Okay, this question is probably the most, I don't know, annoying to do as a student. Probably the longest question you're going to see with me this week, because it's just a whole lot of writing. It's a whole lot of ratios to comment on. So the question here is to find sine cos tan of P, and then to find sine cos tan of Q. So that's a Q down there. That's a typo. I'm not sure why that didn't really come out through the scan. So my apologies there. So I'm just going to set it up on the side here. How do you feel about the pace? Is the pace okay? Good. I promised you today is the first lesson, and with all first lessons, I like to go really, really slow. It might irritate some people that are very strong with this stuff already, but I don't want to lose anybody. I want everybody to be on the board today so we can move ahead next time. So there's sine, cos, and tan of P. And then we got to do the same thing over here with Q. It's actually more efficient than doing this on the board. It's kind of funny that way. And don't forget, we got our good old friend here, SOHCAHTOA. So I'm going to bring that into the mix. But we do need to do one more thing here. In order to start doing this answer, we have to find the length of RQ. Can someone get the length of RQ? Just hook us up with RQ there for a second. Let's get RQ to. Thanks, Maha. Can you give me a bit more? Do you mind giving me 4 decimals on that? Sorry. Thank you, by the way. So 4.50. Just give me a little bit extra if you don't mind, Maha. I'm gonna pull up my engineering calculator. Thank you. So I'm not giving you a lesson on Pythagorean theorem today, but you could get that length there using the Pythagorean theorem. So if anybody's like, how did I get that number? Pythagorean theorem. So now we're going to go and compute the ratios for sine, cos, and tan of P. I'll try to do this as organized as possible because I'm going to have to label the triangle a couple of times. Which one of these sides will always be the same, whether I choose P or Q? Which one will always be the same? Will it be the opposite, the hypotenuse, or the adjacent? Which one doesn't care about P or Q? Which one of the side labels? Yes, the hypotenuse. So Amir, I'm going to put an H there, and I'm going to put it in black. because that one there is fixed. Now we're going to mess around with P. P, I'm going to use purple to label. So if you have P, this guy is opposite and this guy's adjacent. Conversely, if you have Q, I'll do that in red. So if you use Q here, perhaps I'll just circle it in red, then this would be opposite and this would be adjacent. You see how they flip-flop? So we need to understand how they flip-flop like that, because that's going to help us answer these questions down here. So this one over here is related to P. Let's make that one purple, the lettering purple. You can get a taste of my level of detail now. And let's make this one red. And then this guy over here, we should change the color to something off so that you don't confuse it with the labeling. So there you have it, my friends. We have all the numbers, all the labels. We are good to go. Let's do the purple ones. So we have P. Now sine is opposite over hypotenuse. So this time I'm just going to write O and H, because you don't have, I don't think you need to write the whole word opposite there. So opposite is 4.4959 divided by 5.71. I'm not writing the units here, so I should be careful because I want to be a good example to you. Hey, someone give me that to 3 decimals, please. What do you got for 3 decimals? Let me know in the chat. Thank you, Ram. And don't mind me. I'm just doing extra work on the side here so we don't waste too much time with me typing stuff in. That's very good. Thank you, Zifeng. So let's do cosine. So cosine of P is adjacent over hypotenuse, which is 3.52 divided by 5.71. Very nice. Very nice. Thank you. And finally, thank you, Amir. And finally, tan. So opposite over adjacent. So 4.4959 inches divided by. That's why I don't put the inch symbol, because it confuses it. Thank you. Thank you, thank you, thank you. So let's go over here and do the same thing with Q. So now you're using the red letters. So the red letters, here we go. 3.52 over 5.71. What do we have there? Oh, wait a second. We don't need a calculator for this. Why is this one easy? Tell me in the chat, why is this one easy? Do you notice a trick or a shortcut? Who sees the shortcut? Yeah, the answers are there already. So I'm going to do a little bit of arrow, a little bit of magic arrows here. Those ones crisscross. You see they crisscross. So I want you to think about why they might crisscross as I start copying and pasting here. I know I'm going a little quicker on this one, but why am I so confident that those are like that? Why do they crisscross? Let me know. Let me know in the chat. Why do these numbers crisscross? Why is this number? Okay, so you're gonna have to think about that one. You're gonna have to think about that one. Similar triangles is a worthy guess, but not quite what I was looking for. Someone had the answer to this one, by the way. This one I need to do on the calculator. So please get that. Who has an answer to that? I'm so sad. My engineering calculator has lost its batteries. It's done. It's very sad. Thank you, Zifeng. Okay, so let me explain why those crisscross. I'll just type it here. Rocco, if I could high five you, my friend, I would do it right now. That is an absolutely amazing, perfect answer. The sine and cosine ratios crisscross. I spell Chris right? Is it like with one S? Or whatever. I'll just use the word alternate. I give up. They alternate because, like you said, the opposite of P is the adjacent of Q. And vice versa. Very, very good. Very, very good comment there, Rocco. You are exempt from answering questions for the rest of the day because you've proven your might. So those are not exactly the same color, but this pink thing here is supposed to be this pink comment down here. So I got another 5 minutes with you or so. I do want to stick to my to the proper protocol, which is to finish 10 minutes to the hour, as your other professors should as well. I do have some questions for you related to this, and then you can try the next question on your own. Very easy homework today. All I want you to do for homework is the next two questions. So you can do this one on your own and number 4 on your own. And the answer key is at the end of the section. So just try the next two questions on your own. But I do have some questions for you here that are going to pop up later, but I might as well just talk to you about them here. So big questions. Can sine ever be greater than 1? So those 3 questions, I want you to think about those with me before we finish class today. I feel like we're on a game show. Okay, so is this yes or no? First one. I got a no here so far. Anybody, any other takers? Anybody else? I'm not saying if you're right, Shalon. I just want to see what everybody else is thinking here. Let's make it democratic. Okay. Well, if only 2 people vote, is it really democratic? I don't know. Okay. Yeah, the answer is no. Can you explain why? Thank you, Mike. Why is it no? Tell me why it's no. I'm showing some mercy because I know you're probably a little bit tired. You have a long day today. No, because the numerator is always less than the denominator. If the numerator is less than the denominator, then how could it ever be bigger than 1? It would definitely be a strange triangle. The same thing is said for cosine. But for tangent, yes. As long as the opposite is greater than the adjacent. So yeah, there you go. And you can see that right here. For that last one, I'm going to use the numbers on the screen here to just emphasize. So this yes is confirmed right here. See that 1.277? That confirms that. But like you noticed, the first 2 questions, you cannot argue the first 2 questions strictly based on these calculations, because these calculations only represent one example out of an infinite number of examples. So to prove or disprove an argument or a statement like can sine be greater than 1 or etc., you need to think about the definition of sine. So we know that sine is opposite over hypotenuse. I'll just say OPP. And for that reason, it's clear that the numerator will always be less than the denominator because the hypotenuse is the longest side. Same thing with cosine. And finally, tangent, I'm just going to put out the definition here, just so we have it, so that we're all happy and feeling good. Because that's all I want to tell you today. You are free to go, my friends. Go enjoy your afternoon. Go do some work. And make sure that you get that assignment in for Friday. So I know you had a test last week. You as well. Thank you. I know you had a test last week, but you still have an assignment for me due every Friday when you don't have a test. The assignment's fairly doable, nothing too dangerous. I think it's only 2 questions. Just make sure you get that in for me by Friday, midnight. Okay. Thank you, everybody. I'll stick around for questions.